7 and 9 and 11. So those y'all should be good with because we had those on the test. So I'm gonna write in the chat 1, 7, 9, 11, 17. Let me see what other, and 21. So even if you don't know how to write the solutions, graphing those, that was on the test. So those problems you should at least be able to graph, even if you're not sure. Yes, we're on 4.1, Anthony. Even if you're not sure how to write the answer, you at least should be able to come back with graphs. So I'm going to give you a little bit of time because that's a lot of graphs you're going to do. Remember, you're graphing 2 lines on the same graph. So for number 7, here, I'll share my screen. So for number 7, you have 2 lines and you're putting them both on the same graph. So, I mean, I don't know what these lines look like yet, but for example, it might look like, oh, wow, you can't see that, hang on. It might look like this and this, right? Whatever it looks like when you graph it, but you are graphing both of those lines on the same graph. Maybe this one looks like this and this, whatever it's gonna look like. And then wherever they intersect, that is your answer. That point that they intersect is your answer. So just a quick little review of what we're doing. Okay. All right. Okay. Ready to go to groups? No, yay, we're ready. We're just like, we're here, we exist. Okay. All right, here we go. Let me make sure that, okay. All right, there we go. For each one.
Okay.
So what'd you do?
For A, I got yes, because if you just directly substitute the X's and Y's, or the 3 and the 1, both of those equations check out that way. And for B, they do not.
Okay, so I'm just writing it real quick so people can see the work. You said you substituted it in, so I'm just substituting it for you. All right, so the first one was a yes, and then you have to have that work to support it, right? You can't just put a yes.
Yeah.
Well, okay. All right.
Something to support it. Maybe you're missing this line or something. I don't know, but gotta have something to support where your answer is.
Gotcha.
All right, and then for B, you did the same thing. So I'm gonna go through and change it. For B, I'll use a different color so it's obvious I've changed it. So it was -3 here and then a 4 here. So -6 minus 24. Oh, that does not work. No. And there's no point to even do the second one if the first one doesn't work. So you already know it's not going to work. All right, cool. Thank you. Let's do group 2 for number 7. So Charmaine or Joshua or Kayla or Michael L. For number 7.
For the solution, I got 0, 2.
You gotta tell me what you did.
I graphed it. The y-intercept for both just happens to be 0, 2.
Okay, so that's here for, okay, and then?
For the first one, it's up 1 over 1, the whole way up.
Okay, so
and
I'll try to draw the line. Hang on, let me try. It's so difficult on here to draw it. Nope, that looks terrible. Kind of close. Okay, next one.
And for the other one, it's you go down 2 and over 1.
Okay, 1, 2. So here.
Yeah.
All right, so I did notice on the test that I did get to grade. There were definitely some people who did not have graph paper. When you try to find solutions like this without graph paper or printed graph paper or something, it's not gonna work. And honestly, the couple I graded that didn't have graph paper, I couldn't even figure out your graphs anyways, because it was so small or squished, or the lines weren't correct. It was so hard to follow. So please print graph paper or buy graph paper, one of the two. You can go to ACC and use the printer there for free. They probably will even give you graph paper if you go to Learning Lab maybe or somewhere. I'm sure there's a place, right? Matthew, would they give them graphing paper in the Learning Lab? Oh, I thought you said you had worked.
They just make them print it out usually.
Oh, but still, print it out.
Yeah, it's
I know Highland, when I would go, they would give me free graphing paper at the accelerator.
Yep, there you go. So those people who didn't have graph paper, your tests were hard to grade, and it's going to be really hard for problems like this because you can't accurately see the answer. All right, so what was the answer that you said, Joshua?
0-2.
0-2, awesome. Cool. Is that what everyone else got?
Yes.
Awesome. All right,
Yes.
group 3. So we have Alondra, Caitlin, Terry, and Vanessa.
I got 2-6. We got 2-4.
How?
I just graphed it like normal. I started with like the first one. I just put it in the 1, and then I went up 3 and side 2.
Okay. 2, 3, 1, 2. All right. I hope I didn't go up too many that time. No. All right. Let me try to connect it. Try my best. Ooh, that one was pretty good. Okay. And then your next one?
And then the next one, I started on the 5 and then went up 1 and then to the -2.
Oh, okay. So up 1, right 2?
Yes.
Okay. 1, 2. All right. Up 1, 1, 2. All right. That's one way. Or what else could we have done? What's another way besides up 1, right 2? What's another thing we could have done?
Down 1, side 2.
Yep, exactly. Down 1, right 2. Oh, look, it's going to intersect right there. Cool. Cool, there we go. All right, and then what'd you say your answer was again?
2-4.
2, 4. Is that what other people got? Yep, I see nodding. That's good. Awesome, cool, thank you. Oh, does anyone still copying that? No? Okay, cool. Next one. Okay, number 11, we're at group 4. Brian, Carson, and Gina.
I don't have like actual graph paper, so I may or may not be wrong, but I got -2, -2.
Okay, can you tell me what you did and we can do it on the graph here?
So because the formulas aren't in y equals mx plus b form, you gotta solve them and put them in that form.
Okay.
So I got y equals -x minus 4 and y equals 1/2 x minus 1.
So on that one, you added the x first and then you divided the 2, right? And you divided both sides by 2. All right, just in case anyone wasn't sure how we got that. All right, so plus, oh, I'm sorry. It was 1/2 x. And then you said it was -1?
Yes.
Okay. All right, and then graphing?
You start at -4 and go up 1 into the left 1. And then you can do it the opposite way too, to down 1 into the right 1.
Okay.
And then for the other one, you start at -1 and
Hang
go.
on, let me try to connect this.
Oh, sorry.
Hang on. Okay, I think that's pretty good. All right, next one.
And
All
then
right.
you start at -1 and go up 1 and to the right 2.
1, 2. Okay, 1, 1, 2. And you could have done the same thing going the other way, right?
Yes.
Down 1 and then left 1, 2. Oh, look at that. They intersect. That makes it easy when they actually intersect at like a nice point. Makes it a lot easier to make sure your answer's right when they intersect like that. Okay, and then what'd you get as the answer?
-2, -2.
Okay, everyone else get that as well?
You said -2, -2. It's not -2, 2.
I got -2, -2.
Yeah.
Yes, -2, -2. Sorry, oh man. So yes, I got it.
Okay. It's okay. All right, thank you. And that was Gina, right? Or Carson? Who was helping me?
That was me.
Oh, Carson. All right, next one, group 5. Anthony, Ganya, Jade, and Kathleen.
So I didn't get this far, but do you think you could walk me through it?
Yeah, we
Or-
can go through it.
Okay.
So based on what Carson did on number 11, do you want to do the same idea she did or Carson did, which was moving everything to one side to make it y equals, or do you want to use another method?
That's what you would do, right? Because it's not in y equals format.
I mean, you can also find the intercepts and graph it that way. You can make a table, like there's lots of ways.
Okay. The way Carson did it, you would just turn the x to the other side, right? And it would become positive 2x.
Yep, exactly.
So 40 plus 2x.
Yeah, I'll write it over here.
Okay.
So 4y, can you see that or is it too dark?
I can see it.
All right, equals 2x plus 4. All right, then what would you do?
That is hard to see.
Okay, here, let me try to write it lighter.
Much better, thank you.
Okay, yep. And then what would you do?
Would you divide the 4y by 4?
You divide everything by 4, right? Both sides.
Okay, yeah.
Mm-hmm.
And
So
it would just be y.
So y
-2 x? Or
2 divided by 4. What's 2 over 4? 2 over 4.
2.
2 over
0.5?
4. Reducing 2 over 4, what's that?
1/2.
1/2. There you go. 1/2 x
Okay.
plus, what does the 4 over 4 become?
1.
All right. Do you think you can graph it from there?
Would it just start at 0.5x between 0 and 1?
Oh, we actually start at the y-intercept.
Okay.
So this number is our y-intercept. That's our starting place.
I see. Okay.
So we're going to start at 1.
And then would it go up by 1 to the right 2?
Yep, exactly. Good.
Okay.
Good 1, 1, 2, good 1. I'll just write a few there so I can try to connect it properly. I hope it connects. Yep, that looks pretty good. Okay, and then I'll use pink for the other one. How would you graph the other one?
Does it need to be graphed?
Yeah, it's
I mean, not graphed, I'm sorry. Does it need to be solved, or it's already in the correct format, right?
Yeah, I mean, it looks like that's the M right there, right?
Yeah.
And then the B is not there. So what does that mean that the B is?
Nothing, it'll just be horizontal, right?
No, just because the B is missing doesn't mean it's horizontal. If the B is missing, that means it's a 0, right?
Mm-hmm. Yes.
So that's like if I had a +0 right here. Horizontal is when you have no X. So horizontal is if it was like y equals 1/2, then it's horizontal. There's no X.
Okay.
But in this case, there's an X, so it's still a line. It's still a diagonal line. All right, so since our B is 0.
It starts at 0?
Good.
Okay.
And then?
The same, it goes up by 1 to the right 2? Okay.
And then up 1, right 2. Oh, what's happening? Up 1, right 2. That's interesting.
Yes.
Parallel.
Yeah, they're going to be parallel. So what does that mean? Our solution is?
Have the same slope.
No solution.
Yeah, no solution.
Inconsistent.
Yep,
It's
inconsistent.
inconsistent.
Good. No solution, inconsistent. Yep, parallel. Nice. That was a good example to have. So then in case you run into one of those. All right, awesome. Well, thanks for working that one with me, Anthony. So let's hop back to room 1. And this time let's have someone else help. I think Michael helped last time, I believe. So if we could have Fidel, Jerry, or Taylin help with 21.
Yeah, I could help with 21.
Okay.
For the first one, I put it in y equals mx plus b form.
Okay. So you added the 3y over, I think. So if you add the 3y to both sides, that means we have 3y plus x equals 4. What'd you do next?
You move the x.
Okay. So you get negative x plus 4. And then
Divide or get rid of the 3 by dividing. So
oh yeah, each of them. So y equals negative 1/3 plus 4/3. Yuck. That one's hard to graph.
And then for the next one, I did the same thing. So
Okay.
sorry, it's just so hard to see on my phone.
Yeah, I know.
So this one, I moved the 2x over, so I got 6y equals negative 2x plus 8.
Okay, and then?
And then to get rid of the 6, you divide by 6.
Okay.
And then you're gonna, and then we're gonna reduce, so it's gonna be negative 1/3.
Okay.
Plus 4 over 3.
Plus 4/3. Oh, wait, isn't that the same thing?
Yeah, so they're gonna be
It's the same
overlapping.
thing. Yeah, okay. Well, let's try to graph it though. If the 4/3 makes it sort of difficult to graph it.
I kind of estimated to where it would go.
Well, if we want to be more accurate, we might want like a table or something. We at least need to get one point that's an accurate point, and then we can use the slope. Let's see, what could we try? Does anyone have an idea of what we could try to plug in for our x to get one good point?
Yes, -3.
Okay, sure. Let's try plugging in -3. So if we plug in -3, we have y equals negative 1/3 times -3 plus 4/3. Is that going to give us a nice number? Give us -1 plus 4/3. Ooh, that's still a fraction.
Let's take fraction.
Yeah. Can we?
I got -2.
-6.
-2. I heard -2. All right, let's try -2.
-2 and 2.
Okay, cool. Let's try -2. -2. So let me plug in -2. So y equals, that's 2/3 when we multiply, plus 4/3. I think that's 6/3, right? Oh, that's where you got your 2. Okay, cool. So now that we have a nice point to start with, we can just use the slope. All right, so 1, 2, 1, 2. So that's here. And then we're going to use the slope, right, Jerry?
Yeah, so we're gonna go up or go down.
Okay, down 1 and then
3 to the right.
2, 3. Yep. Okay, cool. Down 1, 1, 2, 3. Ooh, looks like that would have been a nice one too. 1, 2, 3. If we would have plugged in 4, that's okay. All right, let me try to connect it. Okay, looks pretty good. All right, so since it's just one line, since they're the same thing, what's our answer?
Infinite solution.
Yeah, infinite solutions, all real solutions, right?
It's independence. It's an independent.
Independent, yeah. Or dependent?
It's dependent.
Dependent. Independent would have been the ones that
Yes,
make
yes, it's dependent.
Yeah.
It's not all real solutions though.
If it's the same line, why is it not all real?
It's solutions that look like that line. It's not any and every real number out there.
Well, you can put all x's. The x's are all real solutions, right?
Yeah, but your solutions to
So it'd be all real numbers. X is all real numbers.
x can be any real number, but the solution itself looks like an ordered pair.
Yeah. So how would
It's
we
that line.
simplify this out? How would we want them to write their answer then? Can they just write infinite?
I would like to see the set builder notation.
Okay. All right. So if we say that it's x can be any real numbers, then we need to also plug in the y. So how do you want them to do it then?
So it should look like an ordered pair is what your solution should look like.
But as a line, right? That's what I was thinking. Like this.
X comma, I would just go X comma Y.
Oh, really? You don't have to make
Yeah,
it
X comma Y, and then you do a line, and then you do the equation of the line.
Okay. All right, we can do that. I've
Because
seen it the other way where they put the
because I can pick numbers like 3, 3.
Yep.
And that's not a solution to that.
Mm-hmm.
It's not on those graphs. It's not.
Yeah, it's the x that's all real solutions. It's anything for the x. You can pick any x. It's just that the y has to depend on the equation.
In this case, teachers, we can say just it's the infinite solution and it's dependent.
No, you have to write it in set builder notation is what Professor Sievers was just saying. He wants to see it in this notation, or we want to see it in this notation.
Can you say it again, Professor Matthew?
Yeah, so you're gonna do one of the swirly brackets for the set builder notation, little swirly ones, and then you'll put the point and just x, y inside. So parenthesis x comma y parenthesis.
Okay.
And then you'll put a vertical line, which means such that in math. And then after the vertical line, you'll write the equation. So y equals -1/3 x plus 4/3. And then you'll close with the swirly closing bracket.
Okay, thank you.
Mm-hmm. Yep. Cool. All right. Everyone wrote that down, right? Nobody's out there sleeping or stepped away from the computer and missed it and won't know how to write it. So many people without their cameras. I don't know if they're here and they're getting it. All right.
So when we have a problem like number 21, that would be our answer.
Yeah.
Okay.
Yeah, so any x works. It's just the y's depend on the x. So you have to write it that way to show that any x will work. And then if you plug it into that equation, that will give you your y, and that's the point.
Okay, thank you.
Mm-hmm. All right. Well, any other questions on that one? I hope everyone's here and heard it. That's the problem with virtual. See so many cameras off. I don't know if they're actually here. All right. Okay, so let's go down. So now we're gonna work on 29. Let's do 33, and then we'll come back because I wanna go over 33 just to make sure y'all understand it before you do 45. So we'll be in our groups for a short time this time. So 29 and 33, I'll type it in the chat as well. 29, 33. Okay. All right, you'll be in there for a short time.
The link to the chat.
Okay.
Everyone join the group me if y'all can. Because for my other classes, it helps a lot to like be in a group me with like your classmates. So I'm just saying for algebra, we don't have one, and it would be very helpful if everyone joins it.
There's also the Learning Lab tutor request as well. So there's a lot of resources out there for y'all. You can get in groups, you can work together, you can come to my tutoring with the professors, you can come to tutoring with the Learning Lab, which some of them are professors as well. Like there's a lot of ways. You can come to our office hours. Like there's a lot of ways. Something I wanted to point out, Because when I went into groups earlier, I noticed the same thing as when I went in the first week, right? This syllabus is a contract, right? The syllabus is a contract between you and me and Professor Sievers. So what that means is you have to uphold your part of the syllabus and we have to uphold our part of the syllabus. So for example, if we just decided, oh, we're gonna make homework worth no percent now, like we would have to reissue like a syllabus and actually put that in writing and talk to you about it because it's a contract. So as of right now, we are all following this contract, right? Does everyone understand how syllabi work? Yeah. So my thing is that some of y'all are not following the contract. Because right here in the contract of expectations of this course, it says students are expected to be active, participating in their groups. That doesn't mean we turn off the camera and we go take a nap. We turn off the camera, we go watch some TV, we disappear, we don't talk to anyone. This is the expectation of this course. So I've had students come and talk to me and say like, nobody in my group says anything. So how am I supposed to get help? Like I'm stuck and I ask and no one says anything. So that's not the point of this class. This isn't a distance learning class, right? We're not just going off and doing our own thing whenever we want. We're in class together. This is the expectation of this course. Now, if you are going to refuse to follow the syllabus and you don't want to meet the expectations of this course, please message me, private message me, or private email us and tell us like, hey, I'm not going to follow the expectations of this course. I don't want my camera on. I don't want my mic on. I'm not going to talk in my group, and I'll put you in a group by yourself. Because the people who want to work together and want to talk and want to get help, they should be together. They shouldn't be in a group with people who aren't doing anything with them, because that's not really fair. We came in here to work together and learn together, and that's the expectation of this course. Okay. So if you don't want cameras on, you don't want mics on, you don't want to participate with a group, send us an email, send us a private message, tell us, and we will put you in a group by yourself from now on so that you don't have to worry about it, because that's the expectation of this course. Okay. All right. Are there any questions on the expectation? I just wanted to bring that back up because I noticed there's a lot of people that aren't following it. Either they're not following it because they didn't know that they need to do it. They forgot from day one because we had so much information we told you, or there's some people who don't want to and are refusing to. And if that's the case, like I said, let us know. We'll put you in a group by yourself. So any questions on the expectations? No? So this is our contract. So feel free to reference it anytime you need. If you have questions about late work, like this is our contract right here. Also, keep in mind, the reason we do not accept late work is because we dropped 4 things. We dropped 4 homeworks. So if you're sick and you can't turn in your homework, you don't have to email us. We're going to drop 4. So just have that be one of your 4. Like you don't have, I mean, it's nice that you let us know. So we're like, oh, I'm sorry. Is there anything we can do to help you? But you don't have to stress out about turning it in late because we dropped 4. So it's like, okay, I'm sick. I can't turn this in time. It's okay. It'll be one of my 4 that's dropped. So that's how we kind of balance the scales. We take away that stress of turning in something late by dropping 4. Are there questions on that? No? Okay.
Oh.
All right. Just wanted to bring everyone's attention to this because I know sometimes day one we go over all this and it's so much information and y'all forget. So I just wanted to bring it back up. Okay. All right. Whew. So back to this. We were at group, I think 2. I think we were at group 2. So Charmaine, Joshua, Kayla, and Michael. I don't remember who helped last time. I think it was Joshua. If someone different could help with number 29.
Yes.
Charmaine or Joshua, I think helped last time. Charmaine or Kayla or Michael L.
Oh, I did the wrong one.
Oh, you didn't do 29?
No.
Okay. Charmaine and Kayla?
So I guess I can go ahead and try to do it.
Awesome.
Basically, I changed out the form to be y equals mx plus b. So I moved everything around. And then I went ahead and subtracted 5 from both sides. So I had negative 5x on one side, and then
One moment, just clarifying.
equals 2. Oh, excuse me, I divided both sides by 2. So that gave me negative 5 equals 2x plus 5.
Wait, where'd the negative go? Don't forget there's a negative right there.
Oh, yes. Yeah.
Okay, awesome. All right, so what do we get when we simplify?
I don't think you can divide 5 over 2 to anything.
Well, we could just write 5 over 2x then, that's fine. And then what about the 10 over negative 2?
You can divide that one by 5.
So you get 5? Okay. All right. Oh, yes. What do we notice? What do we notice 5, happens here again? Like that other one we talked about. What happened?
It's an infinite number.
It didn't. Oh wait, I'm not quite understanding what you mean actually.
Oh, what do we notice that happened? Just like that one of the problems we did before. These are our 2 lines, right? What do you notice about them?
They're the same.
So what is that?
Parallel.
Oh, wait, not the same and parallel. It's not the same thing.
Or one on top of the other.
Yeah, they're coincidental. I mean, they're on top of each other. Okay, so they're the same line. All right, so how do we write our solution? This is good practice because we just did it on the previous one. The swirly bracket.
One moment, we just did an interpreter switch. Sorry, right in the middle of the problem here. She's trying to pin me on the screen.
Oh, it's okay.
Oh. Okay, so for the answer, we're going to have so x, you're going to have the swirly brackets and then x equals 5/2.
Ooh, don't forget to put the point first, x comma y. And we draw the line and then you put the equation.
Okay, gotcha. Now I see the format. I hadn't gotten quite that far, so yeah,
no problem. All right, did everyone else get this? Get the same thing? Yeah.
Did you do substitution for this?
You could, yeah, but then you're still gonna have to find a way to write your answer, your solution.
Oh, okay.
Yeah.
How about if we say it's the infinite number of solution and it's dependent? All we need to give the interval.
So that's what I was asking Professor Sievers. Are you cool with them saying infinitely many solutions, or do you want them to write the set notation, even if it's like not graphing?
I really want to see that set notation.
Okay, there we go. So you all got to practice that. You need the set notation. So make sure you're starring it, jotting it down.
Okay.
All right. Okay.
For me, when I did this homework, I just did it's an infinite solution of it's an infinite number of solution and it's dependent. I didn't give the set. Okay.
All right. No, good thing we went through it. All right. Thank you, Charmaine, for helping me with that one. Let's go to the next group, room 3. So Alondra, Caitlin, Terry, and Vanessa for number 33. Alondra, Caitlin, Terry, Vanessa.
Sorry, I thought you said that we were going to do that together.
So, no, I was saying we'll come back quick because I only gave you 2 problems. That's okay. What about someone else in your group? Vanessa, Caitlin, Alondra?
Well, let's you and I, can you do it with me?
Sure.
Okay.
So the directions say to use substitution. So that means we have to get one variable by itself. We get to pick which one. To me, X looks like the easiest because it's already almost by itself right here. Do you see that?
Yes.
So if we just move the 3y.
Right, negative 3x. I'm sorry, negative x on both sides.
Oh no,
right?
we want the x alone. So move the 3y, get rid of the 3y. The idea of substitution is to get something alone. Yeah.
So in substitution, do I always do the x?
No,
alone?
You can pick the variable. You just have to get one of them by themselves. Now, sometimes the problem gives it to you that way. Like look at 45. Do you see how y is already by itself? So you could skip this step on 45 because they already did it for you. But on 33, we have to make one of the letters, one of the variables alone.
Okay, x equals 3y minus 9 divided by 1, because I guess it's just 3y minus 9.
Yep.
X equals 3y minus 9.
Yep, exactly. So
and I do the other one. 3y minus 9, then I plug 2, I have to think about it. 2 times 3y minus 9.
Good.
Plus 5y equals 4.
Good.
And that's 6y minus 18 plus 5y minus 4 equals 4. Sorry, equals 4. 11y minus 18 equals 4. So you put the 18 positive on the other side. 18. You have 11y. Oh, shoot. 11y equals 22.
Good.
Divided by 11, y equals 2.
All right. So that's one of the, we got y, now we need x. So how could we get x?
So you plug the 2 into the x equals 3 times 2 minus 9.
Good.
Equals 6 minus 9 equals 2, negative 2.
Okay. All right, now we're not done. We need to write our answer as a point. We can't just leave it like this. So we're gonna write our x first, negative 3, comma, and then our y, 2. So that is our solution.
Oh, I'm sorry, negative 3. Okay. I'm counting. I'm like this. I'm counting. I'm sorry.
It's okay.
You're right. Negative 3, 2.
There we go.
Okay. Cool.
All right. So any questions on that one? There's still a whole bunch of people without cameras on. We need to get this fixed, y'all. Whole bunch of people. All right, so I'm gonna put you back in groups. Work on 45 to 49. So we're working on 45 and 49 because 45 is very much the same as what we just did. So I want y'all to practice what I just went over. And then 49 is elimination. And then we'll come back and we'll hopefully get time to go over 49. Okay. All right, let me put you in groups. So I want to start with 49 because we're at the last minute here and I want to at least do one elimination question. Could I get a volunteer for 49?
Yeah, I didn't get to 49.
Did anyone do 49 or anyone know elimination and wants to try it?
Yes, I did.
Okay, somebody want to volunteer?
For which, 45 or 49?
49. Because I want to at least do an elimination one in these last minutes.
Yes, I can do it.
Okay.
Okay, we have the equation system for the first 5x minus 3y is equals to minus 1. And the second, it's 2x minus y equals to 2. Because it's by elimination, I just times the second equation by minus 3.
Okay.
And
on
then
both sides, right? Both sides.
Yes, both sides, yeah.
Okay.
And then the equation, it's going to be minus 6x plus 3y equals to 6.
Negative 6, right?
Negative 6, so yeah, because it's minus 3.
Now, just so the class knows, why did you choose to multiply by negative 3? What may help?
Because I need to erase both sides for the y's, and I wanna just find the x and to replace it. Yeah.
Do we always have to eliminate the y?
No. Depend what's the numbers you have in your y's and your x's.
Okay, good. So you pick the easiest. Make your life easy. And in this case, the y was the easiest.
Yeah.
Yeah. Okay.
Sometimes I don't know how can I explain.
Yeah.
Yes, I did this, and in the end, it's going to be my equation is going to be 5x minus 3y equals to minus 1, and the second is minus 6x plus 3y is equals to minus 6. Because it's by elimination, 1 plus 2. I will number them 1. The first is 1, then the second is 2. 1 plus 2 is going to be by it's not elimination. I am going to have minus y, okay, minus x equals to minus 7, and the x equals to 7.
Good.
Because, yeah, I think it's clear.
7, and now what do we do?
I want to change my y's in the first or second equation to find my x. No, to find my y, sorry.
So we're going to plug in to find y.
Yes, because I have 2x minus y equals to 2. Because my x equals to 7, it's going to be 14 minus y equals to 2, and y equals to 2x minus 2. And
wait,
then in the
did you choose the first equation to plug the x in, or the second equation?
I pick up the second one because it's the easiest one. I have just x minus y because I want to just move on the side. Yeah.
Does it matter which equation you pick?
It doesn't matter. The result is going to be the same. And my y is going to be 12 because 2 times 7 minus 2, it's 14 minus 2 is going to be 12. And my set is for xy is 7, 12.
All right, good. So then we have to write our actual answer, like you said, the set.
Yes, now when I heard my professor say they were doing it, but I didn't. Yeah.
Yeah, I'll write it in blue so y'all know that is the answer. This is the actual final answer.
Yes. I hope I am clear, right?
Yeah, thank you for helping me.
Thank you. No problem.
All right, so I know we're at overtime here. I'll go back and do 45 if people want to stay, since y'all have already worked on that. Any questions on this one? Goodbye for everyone who has to go.
Okay, thank you. Have a good day, everybody. Thanks.
Have a good day.
Have a good one.
Bye to you too. Bye.
I still don't understand how we got -3.
Oh, because we wanted to get rid of one of the variables. So our options are, we have the 5x and the 2x. So we can try to make them the same and eliminate them. Or we have -3y and a -y. So she was thinking, okay, if I have to make them the same, think of like common denominators. Like I have to make them almost the same so that they eliminate. So she was thinking, okay, if I multiply this one by a -3, then I'll get a 3y, a -3y and a +3y, and that will eliminate. Will cancel. Yeah, so think of it as similar to getting a common denominator, like a similar idea, similar concept. Otherwise, if you did the other one, you'd have to multiply this one by a 2 and this one by a -5, right? And that would just be more work.
Okay.
Yeah, so she was like, okay, what's easier? All right, any other questions on this one before we go back and look at 45? No? Okay. All right, let's scroll back up. Anyone want to help me with 45?
I just took the equation from the first line, -2/3 x plus 5, and plugged it in where the y is on the second line.
Okay. Oops, that looks like a terrible 3. There we go. Okay. Oh, equals 11. I forgot the equal sign. And then
and it gave me 2x. Once I simplified it, it was -2x, but I got that by making 3/1 essentially, and then doing 3 times -2, and then the 1 times 3, which gave me -6/3, which I simplified to -2.
Okay. Oh, wow. Looks like our x's might cancel.
Yeah, and then
Oh.
they canceled out and it was 15 = 11, which is a contradiction. So there was no solution.
Good. Perfect. Contradiction, no solution. What does it look like graphically?
Is it just the brackets that's empty inside, or do you do the circle with the...
No, I mean graphically, like on a graph. If I was going to graph it,
Parallel. The parallel.
Uh-huh. Perfect. Parallel. Mm-hmm. Awesome. Cool. Thanks. All right. So, I mean, I can answer questions about 53 or 61. I mean, these are all the same thing we've been doing. Elimination, elimination. So it's more of the same.
I have a question about 65. Is it just wanting us to choose a method and just say which method we would use, or do we want to choose a method then solve it?
Oh, what do the directions say?
It says choose the most convenient method to solve a system of linear equations.
So it says to solve it. It doesn't say you have to solve it.
Yeah.
I mean, I'm always more into more practice, the better, just because, you know, you got to get it in your head. Also look at the answers, right? Don't we have the answers posted? So see if they actually solved it or if they just put like the method.
Okay. I didn't know there were answers posted.
Yeah, they're on there. They're in the book because you have access to the book. So go to the book and just scroll the answers.
Okay.
Mm-hmm. Did anyone else have any questions?
I have a question, and it doesn't pertain to this though. So you were talking about in the lab, you can go, so I can go, like if they're doing math work, I can just go into any group. I have to ask for an invitation.
Are you talking about the black, like the instructional associate?
Yeah.
Yeah, you can just go into any open tutoring lab. So if you go to instructional associate, scroll down, all of these say open hours. That means that you can hop in and just ask questions. Now mine are not correct. I've been emailing my boss about changing it, but all the other ones should be correct. Mine's off because I started a new class that I'm teaching.
Okay. And okay.
Yeah, so if you want to work with Palomino, you just click the link and you ask. If it's Wednesday 4 to 5 and you're like, oh, it's 4:15 and I have a question, just click the link and go ask. Or if you're like, oh, it's Friday morning, I have a question, just click.
And there are other students in there?
There could be, yeah, or there could be nobody if no one's joined. It just depends.
Oh, okay. So you guys just waited for students to come in. See, I wish I would have known that because it was totally different. And I just didn't like, you know, I would prefer for, you know, because I'm used to being at school. And so I would prefer, somebody to sit there and I'm talking to them and they're talking to me, face to face, and me getting the equations. So with 4.1, 2.4, is it 4.1?
Today was 4.1.
For the lecture, right? But the homework last night, I was so frustrated. That's why I didn't turn it in. I couldn't do it. I couldn't solve it. I went on to YouTube and was trying to actually look for somebody that can explain it to me.
Yeah.
Because I wasn't getting it at all. And so I couldn't turn it in. Even though we probably have gone through it before,
Yeah. YouTube is a good resource, but look, for example, last night, let's say it was 4 to 5. You could have just popped in here and asked Madavi between 4 and 5 on Tuesday. Or if it was between 6 and 7 at night, you were doing it, you could have hopped in here and asked Nancy Bella.
Well, see, I do my homework around 9:30 when the kids go to sleep.
Well,
so that's when
if you want help, maybe change your habits. That's why I said, if you're not passing the test, we got to change something, right? If we don't change something, then we won't pass.
I posted the link in the chat of where I went, and it gives you instructions on how to go, or like what you have to fill out. And so basically there was a list of several different professors, and you just kind of choose one. Like it has a short bio for each one. Some of them have
like a different
pictures.
Thing? Oh, it's another thing. Cool.
Yeah,
that's the one. Yeah, but you got an actual person, or you saw the person face to face.
Yeah,
because
and then I just saved the homework, the 4.1 homework. I saved it on my computer.
Right?
No,
they did me bad. But they did me bad.
And then on the top left, there's a upload file or something, a big blue button, and so they can pull it up and they write on it just like we do during classes.
All right.
And so you can also schedule ahead of time or just go through all the professors to see which ones are available. But I think it the cutoff was maybe 4 or 5. I don't remember.
Yeah. So there's more. I added the link that Michael just sent too. So you have 3 resources.
I'm like, man, I am trying to get this and it's not working.
I would say 1, adjust your schedule a little bit so you're not working when all the help is asleep. And then 2, now you have 3 different places you can go to try to get help. Okay.
Yes. Okay. I have to go get the kiddos now, and you guys enjoy your day. Thank you so much.
You too. Bye.
Bye-bye.
Anyone else have questions? I see there's quite a few people still here. Anything I can help you with?
I'm going to respond to your email here in a second, Professor Wise.
Okay.
All right. Thank you for